Algebra 2, Module 3 test. We've been over Module 3 recently, which has to do with quadratic functions, graphing them, finding where they are, creating them from a quadratic function in standard form. So this number 1 problem is basically a true or false question about this particular quadratic function. And so to answer these questions, I'm going to just sketch out the graph of this quadratic function. And in order to do that, I'm going to create an XY coordinate plane. So here we have it. We have the function fx equals negative quantity x minus 4 squared, x plus 4 squared, minus 6. And the form for the vertex form of quadratic functions, fx equals a times quantity x minus h squared plus k. And for there to be x plus 4, h has to equal negative 4, because x minus negative 4 is x plus 4. And so this is going to be our axis of symmetry. X is equal to negative 4. And in this problem, the axis symmetry is x equals negative 4. Yes, that is true. The maximum value is negative 6. Well, let's check that out. We have our vertex for this quadratic function is the point h comma k, and h is negative 4, and k is going to be negative 6. So if we go to the point x equals negative 4, y equals negative 6, 3, 4, 5, 6, we're going to be right here. So we have our axis symmetry, x equals negative 4. I'll just put that down below. And there it is, x equals negative 4. And we have this point here at negative 4 comma 6. I'll write this over here, negative 4 comma negative 6. And a is negative, so without being too detailed, the graph's going to look, the parabola is going to look something like this. So the maximum value is negative 6. And if the maximum value is negative 6, can there be a minimum value? No, there is no minimum value. So C is false. The function is increasing from greater than negative infinity to x equals negative 4. That is true. And the function is decreasing. We have different limits of decreasing. Well, we're decreasing from negative x equals negative 4 to infinity, but not from negative 6 to infinity. And then a very easy way to do that, of course, or even to verify what we've done here, is go to that graphing calculator, enter it in there. So true, true, false, true, false. Okay, next problem. Identify the domain and range of the function fx equals quantity x minus 9 squared minus 7. So what we have here is a domain, and We can use all kinds of different notations, all real numbers, greater than negative infinity to less than infinity, and our range is really limited by our k value here. So k is equal to -7. So we just have to determine whether we are opening upward or downward. Well, in this case, we don't have an a out front, so a by default is positive and is +1. So we are opening upward. So that means our minimum value is going to be -7, and we're going to go up to less than infinity. So there we have a domain and range. And you can write this in set notation, inequality notation, a lot of different ways. Y greater than or equal to -7. Okay. Just all kinds of things you can do. Any one of which, even in verbal description, would have been correct. Okay, 3. Write the quadratic function in vertex form by completing the square. And so here we have, I'm going to just write this over the side. So what we have is f of x equals, I'm going to create a square inside the parentheses here. So we have x squared minus 2x. And then to complete the square, we are going to add something here. And then we close the parentheses. And then we're going to have to, on the other side of the closed parentheses, we're going to have to subtract whatever we added here. And I'm pointing these arrows to show this operation. And then finally, we bring over this -3. And so now to complete this square, what do we put there? Well, we take our middle coefficient, -2, and divide that by 2, and we get -1. From there, we take this -1 and square it to equal 1. So that means this 1 is going to have to go right here to complete that square. And then, since we've added 1 over here to the right side of the function, we're going to have to subtract 1 to keep that right side of the function consistent. So writing down below, we have f of x equals quantity x minus 1 squared, and on the right side we have -1 minus 3, which is -4. So our answer is going to be, I'll put this in blank, f of x equals quantity x minus 1 squared minus 4. And if you happen to graph these two things in your calculator, you will see that they are equivalent. Next, another completing the square problem. And we're going to do the same thing for this one. Put f of x is equal to, open parentheses, x squared plus 6x, and then plus some number we don't know yet. And then we're going to subtract the same number that we added inside the parentheses. And then we bring over this plus 7. And so we take this 6, the coefficient or middle term, divide that by 2, we get 3. And this 3, we are going to square and get 9. So therefore 9 is going to be the value that we add right in here. So that's 9. And we subtract 9 on the outside. So when we work this out, we're going to get f of x equals, we're going to have quantity x plus 3 squared. On the outside, we have -9 plus 7 we're just going to simplify to minus 2. So, therefore, our completed square is going to look like vertex form f of x equals quantity x plus 3 squared minus 2. All right. Number 5. Does each of the following functions have either a maximum or a minimum value of 3? Well, you'd have to complete the square kind of like we did in that other one, which is really going to be easy to do. Can easily be done. But one thing we have at our disposal is a TI-84 series graphing calculator. So I'm going to make my life easy and just go there, put it in. So the first one we're going to put in is problem A, negative x squared minus 2x plus 2 and so that's it. Graph. I don't see exactly, looks like we have a 3 there. Let's go ahead to the table view. So it looks like we do have a maximum value of 3, and so it's asking if it has a maximum or minimum. So it's a max value of 3, yes. Next one we'll do is this x squared minus 6x plus 3. So x squared minus 6x plus 3. And graph that. No, we do not have a minimum or maximum value of 3. Let me double check to make sure that we entered the second equation properly, which I did. So the answer to this next question is, or part B is false. No. The last one, 8x squared minus 8x plus 19. X squared minus 8x plus 19. See what that looks like. Magenta there. It looks like that might be a minimum. Let's go to our table view. And looks like we have, if we go down to x equals 4, looks like we have x equals 4, we have a minimum of 3. So that checks out. So we will say yes. Next, 6. The model rocket is launched upward at a speed of 96 feet per second from the platform 7. Here we have the equation. F of t equals negative 16t squared plus v sub 0t plus h of 0. This is for the units in feet per second. So if we had meters instead on Earth, it would be negative 4.9 t squared, otherwise the same. We could, let's write out this equation here based on, we have f of t equals negative 16 t squared, and we have plus 96 feet per second, so we have our v sub 0 is 96. We have t plus our initial height, which is 7 feet. So we could go ahead and complete the square, make a vertex form, and do that pretty easily this way. But with a graphing calculator, we even have an easier way to go, which is just to enter this function in standard form and trace or evaluate using the graphing features in the calculator. So I'm going to go for the efficiency in doing that. Let's go ahead and clear these guys out of here. So we put negative 16x squared plus 96x plus 7, and we graph this function That's what you have a hard time seeing that. What happens? We're launching up into the air, and if we check our possibilities in the answers, so let's look for those. If we go to our answers, we say, okay, maximum value after 3 seconds or maximum value after 6 seconds. So if we look at that for domain, that would be helpful. And then we have KC, the maximum height of the rocket being 151 feet and the maximum height being 302 feet. So we can use those possibilities to set our windows. We go to window, we go from x equals 0 all the way to, we'll leave it at 10. And then our y minimum we can leave at negative 10. And we know that we can go up to 300 and whatever it was, 2 feet is a maximum elevation. So I'm going to put 310 feet. I'm going to y scale up by 10. I'll put up to 25. Then we press graph, and this is what we get. So we're not up near 300 feet, so I'm thinking 151 feet. And then our time, we have our x values in our window are 1 apart, so 1 second. So I'm thinking we have at 3 seconds, we reach our maximum height of 151 feet. That's what it looks like to me. You could go to your table view like this and see where that is, but you'd have to go all the way. Well, it looks like we see one right here. It looks like we have symmetry, so that looks pretty good. So time 3 seconds, maximum height 151 feet. You could go back to graph and you could trace. You know, I'm going to use the maximum here. Second, trace maximum, which is 4. And it says left bound question mark, so we can go over to the left of the vertex. Press enter. Now it says right bound question mark. We go to the right side of the vertex, enter, and enter one last time. We get a maximum of, that's 3 with just a very slight nuance around here, and 151. So we can answer everything now. Yes, 3 seconds we reach the maximum height. No, not after 6 seconds, after 3 seconds. The maximum height the rocket will reach is 151 feet. That is the truth. And 302 feet? No. Okay, let's go to problem 7. Find an approximate quadratic function model for the graph data by estimating coordinates of the vertex and using one other point. Now in this one, I'm going to allow a lot of flexibility just because you could choose like 5, 2. I'm going to choose 5, 2.5. Yeah, I think that fits pretty well. So vertex, I'll put 5, 2.5. Now, if you happen to use 5, 2, and everything is consistent in what you did, I'm going to give you credit because you could almost justify 5, 2 right here. But whatever you do, well, I'll check it out, see if it's right. And then use one other point. I think I'm going to come up here and use this point 1, 6. So other point 1, 6. So that being the case, our vertex form of the equation without the a calculator is going to be f of x equals a times x, and we have h is equal to 5. So we will say x minus 5 quantity squared, and then we're going to take plus 2.5 on the outside. Okay, so that looks pretty good. Now let's go ahead and put this other point in here. So we're going to, f of x is equal to 6. 6 is equal to a, which we don't know. And then x is equal to 1. So we have 1 minus 5 squared plus 2.5. The next thing to do is we're going to subtract 2.5 from each side of the equation. So on the left side we have 3.5 is equal to a, and then 1 minus 5 is negative 4. Negative 4 squared is 16. And now if we divide by 16, we have a is equal to 3.5 over 16. And if to get rid of that decimal, if we multiply both the numerator and denominator by 2, we're going to get 7 over 32. 7/32. So therefore, our equation is going to be f of x is equal to 7/32, and we have quantity x minus 5 squared plus 2.5. It says go ahead and sketch the points, sketch in the graph. Here's what I'm going to do. I'm going to go to zoom standard, which is zoom 6. I'm going to also press second format and get the grid lines here. So I do that. That helps. Get the proper equation here. And you could put 3.5 over 16. Now yours is probably not exactly the same as mine in that you have latitude in picking what your vertex is and also which other point you happen to use. So I'm really just checking for consistency. We have x minus h, and h is 5. We're going to square that and add 2.5. And we graph this function. This is what it looks like. Okay. So 5, 2.5 check, 6, 1. And so I'm just going to use those points of symmetry on this graph here. And so we have 6, 1. And so we went 5 to the 1, 2, 3, 4 to the left, and up to 6. So 1, 2, 3, 4 to the right, up to 6. So these points are going to be on there like this somehow. Again, in this sketch, I'm not looking for anything close to perfection. You can see by mine, my sketch is nowhere near perfect either. So you're going to look for something like, I'm going to look for something like this. Now we'll call that good enough. And let me just put the equation down here in the proper blank. We have f of x equals 7/32 for quantity x minus 5 squared plus 2.5. Okay, let's go ahead to problem 8. The given parabola has a vertex at -4, 3, and another point at -2, -5. So in this case, h is equal to -4, and k is equal to 3. So our basic function is going to be f of x equals a times x minus h, so x minus -4 squared plus 3. And minus -4 is the same as plus 4, so I'm going to just rewrite this as f of x equals a times quantity x plus 4 squared plus 3. And now we're going to use our other point. So for that, I'm going to just circle this and draw my arrow over here. We're going to say -5 is equal to a, which we do not yet know, and x is -2, and plus 4 squared plus 3. Next step, we're going to subtract the 3 from both sides. So we get -8 on the left side is equal to, now -2 plus 4 is 2, and 2 squared is 4. So we get 4a, and dividing by 4, we get a is equal to -2. Okay. So we have everything we need. So we have f of x is equal to -2 times quantity x plus 4 squared plus 3. And we could test to make sure that we have our points. In fact, I'll do that right now. Go to the calculator. We'll put in -2 times quantity x plus 4. Oh, it's quantity x plus 4 squared plus 3. That should get it. We graph. We see we have our vertex at -4, 3. We're opening down. Our one other point was, make sure we have it, -2, -5. So if we go to -2 and then down 5, we hit that. We go to the table view. We see the same thing. -4, 3, -2, -5, check, check. Looks real good. Next, 9. Now 9 I changed significantly, and I was trying to do two things at once. Make the problem a little easier. We hadn't worked with x-intercepts a whole lot. And also using the technology of finding a quadratic function by using the regression feature on the calculator. So what I did before getting this, I put all these points here on the plot into this table, and I went into this table view and put, if I press edit, we see all these points entered. Okay, all these points here are entered right here. And if we go to y equals, I'm going to clear off our functions that we already have. And we press plot and graph, we will see this downward opening parabolic pattern. Next, we're going to use the calculator to find out what that equation is. And for that, we go to Stat, Calc, Quadratic Regression 5. And we're going to go down to store regression equation. And we're going to try to place this equation we will calculate automatically into our function editor. To do that, we'll press alpha y equals. And then on the tabs below, we want this y bars tab. So I go over twice. And we'll put this function in y1. I think that's the blue one. So we do that, press one more time, and a final time, and we get our equation right here. And what I'm going to do is write this down. What we have here is negative 0.45x squared plus 4.65x minus 3.14. So we go to, I'm just going to write the equation down here. There we go, got that cursor up there. So we'll put f of x equals negative was it 0.45x squared we will have plus 4.65x and then we will have minus 3.14, and then in our calculator we go to our function editor and we see the function entered right in place. Press graph. We see all these points being pretty well targeted. So we can go and sketch pretty much through all these points. Looks like the second one here we're not quite hitting as well. So maybe just inside of that one. So it looks like we're kind of coming up like this. Maybe just inside of that one. It looks like it pretty much hit all the rest of these values. So as long as you have something that looks fairly correct like that, this will be a 100% correct answer. And having used these points, you're not going to get any significant function different from what I have entered here. So that'll be that. Okay. 10. The graph of quadratic function has a vertex at 5, -2 and opens downward. Can each of the following points lie on this graph? Well, 5, -2, I'm going to just sketch a coordinate plane. So 5, -2, so we have 5 to the right, 3, 4, 5, and down 2. So at 5, -2, and we're opening downward, so I'm going to put 5, -2, and so we're doing something like this. Really, we're looking at possibilities, so we got to be for a possible point, it has to be below, has to be less than y equals -2. If it's not, if it's on the line of y equals -2, that would be incorrect also. It has to be below -2. So the point 1, -7, could that be right? So 1 and down 3, 4, 5, 6, 7. Could it possibly be here? Can I draw that curve up to the vertex? Yes. Could lie on the graph. 3, -5. So 3, 1, 2, 3, to the right, and 5 down. That could be right here also, couldn't it? Yes. What about 7, -2? Well, 7, -2 is going to be right on this line. So we really can't have that one. So our third possible point is a no. Next, now write the quadratic function for the parabola that has the axis symmetry x equals -2 points, -3, 2, and 0, 11 opens upward and sketch a graph function. What we have for this one is the basic function is fx equals a times 20x minus h squared plus k. In this case, we're given x equals -2 as our axis symmetry, so I'm just going to draw that in here. So we'll put x equals -2. So our vertex is going to be on this axis of symmetry. And we have x equals -2. So that's going to be f of x equals a times quantity x minus -2 squared plus k. And x minus -2 is x plus 2 squared plus k. And so now we're going to use our different points. So I'm going to have on the left, I'm going to create an equation using the coordinate pair -3, 2. And over on the right, I'm going to use that same equation, but for the coordinate pair 0, 11. So using -3, 2, we have 2 is equal to a, and we have -3 plus 2 squared plus k. And just simplifying here, -3 plus 2 is 1, and 1 squared is 1. So we have 2 is equal to a plus k. And then for 0, 11, we have 11 is equal to a times 0 plus 2 squared plus k. And 2 squared is 4, so 11 is equal to 4a plus k. Now what we have is a situation where we have two equations and two unknowns. So I'm going to take this 2 equals a plus k and move that equation right underneath 11 equals 4a plus k and subtract one equation from the other. So we have 11 minus 2 equals 9. And on the right side, we have 4a minus a equals 3a, and k minus k is 0. So now we have 9 equals 3a, and if we divide by 3, we get a is equal to 3. And now we need to find what k is. So I'm going to take this 3 back over here for this a here. So we have 2 is equal to 3 plus k. And subtracting 3, we have k is equal to -1. And so our k value is -1, so I'm going to go ahead and put that in here. And we are opening upward, so I'm going to put the point -2, -1, and we are opening upward. And what are those other points we have already? -3, 2. So we got -3, 2. We have this point here, and we have 0, 11. Well, we can't go up to 11 exactly, but we're going to look something like this. Pretty skinny parabola, so we're going to be looking at something like this. That's what it's going to basically look like. Let's write our final form of the function here. We have f of x equals 3 times quantity x plus 2 squared minus 1. And so that's going to be it. Next, problem 12. Is each set of information enough to create a unique parabola? The vertex in a second non-vertex point. And yeah, that's the one we've been talking about. We've done this several times in this test so far. Problem, we can demonstrate what they are. Problems 8. We had, what else? Well, we had problem 8 might be the best example. But yes, two x-intercepts. Well, if we have two x-intercepts, let's just show what that looks like. You can sort of use it. So if we have a parabola that has two x-intercepts, like these ones right here, well, we could have this looking parabola here, right? Or we could even have a wider parabola. So we're not going to get a unique parabola from just two x-intercepts. So that's going to be a no. If we have the vertex and the range, well, the vertex and the range, and that's helpful to know, but we don't have any idea of what the A is for that. And so this is going to be a no. For part C, the range, the axis of symmetry, and one x-intercept. Well, the range is going to give the vertex, the range and the axis symmetry is going to give the vertex, plus we will have, let me work it over here. If we have the range, let's say we have range of -3 infinity. If we have the axis symmetry, x is equal to 4, and the x-intercept, so we have a range of, we have our vertex at 4, -3, so we have a vertex 4, -3, and we're given an x-intercept. Okay, that's going to be our second point. So we are going to have enough to create, because we'll have our vertex based on the axis symmetry and the range, and the x-intercept is one other point, and so that's going to be a yes. 12B is a yes. So let's go to number 13. Cables on either side of pedestrian assistance bridge are in the shape of a parabola. The towers that support the cables are 100 feet apart and 27 feet high. And so we create one tower 27 feet high and 100 feet away a second tower that is also 27 feet high. And these towers are 100 feet apart. So we have 100 feet. And then we have a cable that is suspended, comes down here like this and goes up in the shape of a parabola. And we know that the cables are a height of 2 feet midway between the towers. So right here, between the towers, we have a cable height that is 2 feet off the ground. And my suggestion, and you don't have to do it this way for sure, but if you let the axis symmetry be the equation x equals 0, then you have the point 0, 2 for your vertex. And so you have the vertex and just one other point. Well, if your center is of this span is at 0, 2, that means over here, the other point you would pick is this one here, which would be x equals 50 and y equals 27. Now you could have also used like -50, 27 over on the far left. On the right, you can be dealing with positive numbers, might be a little easier. So the basic form of equation is f of x equals a times quantity x minus h squared plus k. So in this case, where we have our axis symmetry at x equals 0, we have f of x is equal to a times x, and h is 0. So we have x squared plus k, which is 2. And now we can take our second point, which is 50, 27, and plug it in here. So we get 27 is equal to A times 50 squared plus 2. And subtracting 2 from each side of this equation, we have 25 is equal to 50 squared times A. And so dividing by 50 squared, A is going to be equal to 25 over 50 squared. And now we can use our equation. I'm going to kind of work over to the left now. We're going to say f of x equals 25 over 50 squared x squared plus 2. And now we want to find the height of a cable point that is 20 feet from the center of the bridge. So we can go 20 feet to the right here. So we have, and that's going to be x value of 20. And the point up here is going to be, well, we don't know where it is yet, but 20 is our input value. So we'll put f of 20 is equal to 25 over 50 squared times 20 squared plus 2. And we can put all this in our calculator. We go to that calculator, calculator page here, alpha, enter, we'll put 25 over 50 squared times the x value, which is 20 squared plus 2. And we get 6. So that is our elevation, 6 feet. So basically I should see some kind of equation like this, and we will see what is the height. So let's say 6 feet, or you can say height of 6 feet. I don't really care how you articulate it. Because that's how it was mentioned. That's a height of 2 feet, height of 6 feet. Terms are similar. Okay, good. 14, determine if each function fits a parabola that opens downward and has x equals -5 as an axis of symmetry. So basically you can kind of look at this. Here we have for A, okay, open downward, we have to have A being negative. So all these open downward, right? -5, negative, negative, they're all opening downward. So that's the point. The point is, where's this? Okay, remember we have f of x equals a times quantity x minus h squared plus k. So if we have for h equals -5, we're going to have a times x minus -5 squared plus k. So we're going to have something with a, and a is going to be negative. We have to have x plus 5 squared plus k. And you can look at all these in the calculator to make it really easy. Not really, but so you have to have an x plus 5 somewhere. So we do not have that in choice A, nor do we have that in choice B. But we have x plus 5 in choices C and D. So that's true. Okay, that's our test. I hope you did well. And to the extent you didn't do well, or as well, hope you learned from this. Good luck, and thanks for viewing.